No?
You're fine, I think.
How do I make it closer? Do I hold it? This is really close. Really? Okay. Great, I'll just do this. All right. So, for those who don't know me, my name is Ryan. I've been at Labs for a while now. I'm an engineer on Cloud Foundry. And a lot of the stuff that I've been working on these days has been visualization and front-end related. So I'm kind of excited to talk about what we were working on for a couple of weeks. Basically, as like Rajan mentioned already, there's this visualization which we've built. And Ansi's going to kind of talk about it.
So Ryan and the set of engineers who've been working with Ryan, Charles, can you not hear me?
How about now? Okay. I will just. So they've built a visualization front end for Diego, and so for those of you who don't know what Diego is, and I think we have some fifth floor people who might not, let me just very briefly tell you what it is. Diego is the second generation, possibly third generation, we aren't sure, runtime for Cloud Foundry. Basically, it's a container orchestrator. It can run and manage applications in containers for you. It's a complicated distributed system with lots of moving parts that we distribute via Bosh, and I love Bosh, we all love Bosh, but Bosh is hard. And we wanted to let people play with Diego easily, and so what we did was we asked, is there a way to make this easier? And we built this thing called Lattice. Lattice is just a packaged up version of Diego. It's the same code. It takes the Diego code base, the GoRouter code base, and the Logger code base, puts it all together, and lets you just vagrant up. And there's this hot website at lattice.cf that you can go check out.
Super cool.
It's like HashiCorp. Looking. Is that on video? I apologize. They were the inspiration.
So what we decided to do was we wanted to like visualize some of the stuff that was coming out of this API in Lattice. And you know, we had this like metaphor of like a crystal and seeing into it and seeing the structure of the interior of a crystal to understand like what's actually going on, which is very similar to like what we would like to have for this tool. So this is a scene from the Dark Crystal. I don't know, how many people here have seen the Dark Crystal? Oh, okay, good. So it's not totally lost. But anyways, this is I'll explain it for those who haven't seen it before. This is a scene where one of the characters is being exposed to the Dark Crystal. She's looking into it and seeing the true structure of like what's going on. So I thought that was kind of appropriate. Anyways, introducing xray. That's kind of what it is. Anyways, so here's some of the initial concepts for xray from Ansi, of course. This is kind of like different ways of visualizing the containers that we had. With this, we expected there to be a lot of objects because we're going to draw like every single container that we're going to have, and then we're going to also have like what the operator kind of desires to have as well. And this is going to be connected to a real-time API.
Can I just define some terms?
Sure.
Real quick. So what you're seeing here is Lattice or Diego deploys a number of VMs. We call them cells, and each VM has multiple containers running on it. Each line here represents a cell, and the colored blocks represent a container running in a cell. And in this view, we've scaled it so that the width of the container representation represents the amount of memory reserved for the container. And so you can sort of say, hey, you know, this cell is about 30% capacity, and it's got one container that's taken up a lot of memory and one that's only reserved a small amount of memory. And then there's the colors, and the colors represent different applications. So you might have like a Rails app that you want 4 instances of, and we will just randomly assign it a color, let's say, I don't know, cyan, and you would see that you have 4 instances of your cyan application. And so what you can see with this visualization is, you know, how many different apps are there, how many containers are there, how is Diego distributing those containers, how much memory is there being used in the system, et cetera, et cetera. Does that help?
Yep.
And then this is like a detail view where you can see the name of the app, how many instances are running, and the color to associate it with. All right, take it away.
Yeah. So I might like go into some detail about like what some of these things mean. It's not super, like some of the terms aren't super important, but just think about it as like containers, lots of objects being rendered, responding to sort of a real-time API. And it's sort of we really wanted to make it really obvious what was going on. So it's like, so that people could create a mental model to like what was actually happening in the system as to what's happening on the screen. So it's kind of like this, it's a metaphor for that. So we'd like to start with the demo. Let me go over to this screen. This may not work, but so, you know, whatever. So this is a example of X-ray connected to Lattice. This is by default, it shows like the kind of like what you guys saw in the mock-ups. You can hover over like these containers. This is by memory view, so they're actually sized according to how much memory they have. I can expand the sidebar and we can actually get more information. That's actually like, you know, you have some of that. You can actually go between the memory view and containers mode, so it switches. This is sort of helpful when you just want to like, when you just want to see actually how many things are actually running versus like how much space they're taking up. So there's other interesting features that we have here, like filtering. So if I want to filter here, I can type in, it filters it and highlights it. Oops, if I type it correctly. And I can actually zoom in on one of these as well. I can click here, or I can click on the process here. I can get like a detail of like what's going on, and it actually highlights this. So this is sort of like a running application that you would have. But this is kind of boring because it's not alive right now. So I'd like to have Ansi like.
So this is an opportunity to demo both X-ray, but also the work we've been doing with Lattice. So you can think of Lattice as like a nice packaged up version of the container technology inside Cloud Foundry. And what we've done is we've added a very straightforward and simple CLI that uses the same APIs that like the cloud controller in Cloud Foundry would use to launch applications. When you're playing with Lattice like this, you're typically launching Docker images, and that's what I'm going to do in this demo. So the name of the command line tool is LTC. It's pronounced lettuce. Can you all see? Is that big enough? I imagine it's big enough. Yeah. And so it's got a bunch of commands. That's cool. Let me show you what we're targeted at. We're targeted at a Lattice deployment on AWS. And it's the same thing that Ryan's pointed to up there. And you know, I can list the applications. So here they are. Nudge that down a bit. So the same thing that you're seeing up there, we can see down here. I can get detailed status about an individual application, just like Ryan did. A little bit more information with the CLI. So you know, I can see I have, you know, all 5 instances are up and running. I can see how long they've been running. I can get all their networking information, et cetera, et cetera. And I can even build a little hokey visualization. Hello. Just like, you know, Ryan's, but on the command line. His is substantially fancier. All right, all you've seen so far is getting information, right? Let's start putting and posting information. So let me create a new application. So I have a Docker image called Grace that I'm going to push out. So what you should be seeing behind me is stuff happening on Ryan's screen.
Hopefully.
You might want to reload, I don't know. There we go.
Oh, okay.
So it's up. So Ryan, if you filter for Grace. Oh, there he is. Cool. All right. Ta-da! So what can I do with this? Well, I can click on this. And there we go. There it is. I'm routing to it. I want more. So now I'll load balance between them. I can also get the logs. Okay, fine. I can get the logs. There they are. I set it in chatty mode, so it's just going to say, I'm here, I'm here. So I'm streaming logs from 20 containers onto my laptop. So that's nice. And we can say, okay, thank you, Grace. You know, it appears here. I'm going to remove it. And on the screen behind me, it should have gone. Did it, did it, did it. Awesome. Cool. Okay, so what else can you do with LTC? Well, we want Lattice to be a really cool, fun developer tool. We want to be able to extend Diego by, like, you know, running code on the Lattice VMs and just playing with it. And so being able to debug Lattice was a high priority. And so I can type debug logs. And these are the logs coming from the Lattice components themselves. Like I'm literally like streaming logs from our various Diego components on Lattice. This is super useful for debugging. With a cluster of 10 cells, it's less useful. It's a lot of data, but you know, when you just have your local VM or a cluster of a few, it's actually really useful. And the last thing is this is labs, right? This is pivotal. So it comes with a test suite built in. So it's going to launch a test, and you should hopefully see stuff happening on Ryan's screen. And it'll probably time out because Docker is slow. And you know, the test takes about 2 minutes to run. So as exciting as it would be to show this, it's a green dot. I don't know if you can see. There. It goes by so quickly, it like comes up and then goes away. You maybe didn't see it. All right, cool. So that's some of the features. The last thing is that we've built Diego to be fault tolerant, and I'm about to do this live. I have no idea if it's going to work, but I'm going to go over to AWS and refresh to make sure I still have a session. I'm going to pick, I don't know, 4, 0, 4, and 7, and pull the plug.
I hope it works.
Bye-bye. And Amazon takes a while. And then we take a little bit to notice. So let's see what actually happens here. Diego, save the applications. so you can see that X-ray is like, oh crap, all of these things are dead. And hopefully Diego will restart them pretty quickly. This is the part where we all hold our breath and hope that it works. It shouldn't have to. Yeah, they're still not up. So it'll possibly take 30 seconds for a conversion loop to run. But it should totally work.
It should work. Can refresh it.
Makes for a great demo. Well, I don't know. That normally works. This is why we're in beta. These are my debug logs, right? There they are. So, I'm not sure why. Oh, there it goes! It is supposed to be substantially faster than that. It's possible that this is slightly misconfigured, but we saved them eventually. And because you ran more than one instance, and because we do a good job of distributing instances, almost none of those applications actually had any downtime. All right, that's the demo. Oh, maybe one last thing. Lattice.cf.
So, with all that, it's like, I guess there's a couple of questions that people might have, which is why we chose React. And a lot of it was because of how many containers we actually had to render and how we have to respond to those things, and that we want to actually do animations between these things. Like, you can choose any MVC framework, but I've actually had a lot of experience working with React, so I thought it would be a pretty good choice, and the team was open to like giving it a try. React's kind of different from other frameworks. It's not really an imperative framework. Like if you're going to build something with jQuery or with the DOM API itself, you're not going to like set things directly. You're instead going to like kind of affect change on things. So I'll explain exactly what that means, but you don't really have to worry as much of the DOM API or calling things explicitly. And it's more of that, and it's less of callbacks. So I guess if you guys have done any backbone development, or like even like most of the frameworks actually have quite a few callbacks in JavaScript, and the reality is that kind of stuff is all like, it's all part of like what you need to do when you're building these frameworks, but it's really hard for developers to actually understand callbacks and the code for that. So we tried to minimize that so we didn't have to think about anything, especially if we're responding to all these live events. So getting back to what a React component looks like, here's an example of a React component. So this is some JavaScript here. This would be like all you really need to have on a React component. It just needs to have a render function, and then you kind of return some XML. It's kind of like HTML, and it's inline. It's pre-processed by React. They call this JSX. You can read more about it on the React website. But anyways, I have like some form elements here. I have some things from Pivotal UI actually. Pivotal UI has a bunch of React components built in, so you can get some of the JavaScript behavior from that. And this kind of just renders this. This is the URL. If you're going to use X-ray without a receptor, how it connects to that to the API, this dialog would show up and it would like say enter a receptor URL. Anyways, we use this. It's kind of a nice abstraction to have a function, just the render function. This is what this means in React is like render is idempotent, which means you can call it as much as you want. It's always going to return the same thing. Like in this case, it's always going to return this HTML, as long as the state doesn't change of the underlying state of this component or what is passed into the component. So that's kind of an interesting property because it means that you just draw everything all the time whenever it changes, and you don't worry about it. I talked about this before with other frameworks, but React does an even better job because it has this interesting DOM diffing algorithm, which tries to figure out exactly what changes you've made to the DOM when you've re-rendered it in a different state, and applies those changes only. So the interesting with that means that animations and that kind of stuff works because it actually doesn't delete DOM or replace DOM. It changes everything that you have. There's a few caveats to that because behind the scenes what it actually has is a virtual DOM to represent all the changes, and it's diffing to compute the smallest set of changes. So you start here, something changes the system, then it realizes that there's some change, and it knows that it has to change these three things to move on to the next stage, right? This algorithm is actually, it would be, if you're going to do the most optimal algorithm, which would give you the perfect diff, that would be n cubed, and that's kind of expensive. So they don't actually do that. They actually use a simpler algorithm that's order n, so it's much faster. And if you guys are interested about like how their algorithm actually works, you should read about what they do on the React website. But anyways, there's a better reason to use components, and that's kind of like, there's a lot of things that you want your front end to do, and if you can think about breaking down what your front end does into separate pieces of work, you can have like a really complicated machine like this, but I can make one component that represents just this this one small thing of what it needs to do, and that's kind of like the nice abstraction, and that's what I think React really brings to the table. So here's an example of some components. We've been doing some work on X-ray itself, so some of these screenshots are from the older version. But anyways, it kind of looks like this. Anyways, there's like there's this desired LRP list over here, which is like what you would like to have in the system. Then over here, these are the actual LRPs in cells that are represented on the left-hand side, as you guys saw in the demo. When you're doing this with React, you could represent these things as components. And so by that, I just mean like these XML-looking like components. So this is a zone which contains cells. You can go further here. Like you can talk about the cells within a cell, et cetera, and you can keep breaking down each piece into a really small thing that does a very simple job. So this sounds very similar to like other things that we do in computer science, and it is, because it's like, it's the idea that you should just build something that's very simple that does one job, so you don't have multiple responsibilities, because things that have a lot of responsibilities are complicated and often have a lot of bugs. So here's an example of the sidebar. Here we have a sidebar component. There's a filter, and then desired LRPs. So here's a way to break it down. You could take this whole architecture that I just showed you here, and you could say, well, my entire application is actually a bunch of components. I have an application that has a page, that has zones, that has cells, and the cells have a container. There's actually multiple of these, right? Each one of these is a container in our universe. And then you have a sidebar, and the sidebar has a filter that has a desired LRP list. And you can keep going down and breaking down those things, and that's kind of like, in short, what we're talking about when we talk about component architecture in React. So this is cool because it's, we like HTML because it's compositional. And we like React because it's compositional. If I want to have like two different things, I can take two different components, put them together, and now it does the two different things it's supposed to do in an interesting way. And instead of me having to like think about how these things interact separately, I can just put them together. The complexity is all in the connections between these components. So that does mean that you're not totally free of complexity, but it's been moved from maybe like an individual view to now like a component. So we think that works pretty well, and it has worked for X-ray. But of course, this isn't the total answer, because React really is only the V and MVC. And it doesn't promise to like give you anything else and tell you like what you should do like with your data. So you still need to have like some concept of a domain layer. But you have the freedom to choose whatever you want, because they're not opinionated. They're just like, well, use whatever you want, because it's like whatever data you have is the input to your system. Just use whatever you want. So what should we do? Like, are we supposed to represent things in models and collections and have objects in JavaScript that respond to callbacks? You know, there's a lot of different ways you could represent that. But Facebook has already come up with a solution, which they call Flux. And it's an interesting idea. There's actually, you know, if you look up Flux on the internet, there's like lots of people talking about it, but there's like, and people are like, where's the repo for this thing? And it's like, there's no repo, because it's just an idea. It's like MVC, right? When we look at MVC, we don't go to like the MVC repo and say like, oh, check out MVC, and it's like, now I have an MVC, great. With Flux, it's the same thing. It's just a philosophy and a design pattern that they're talking about here. So it's actually kind of like vaporware almost. But the idea is really simple. It's basically that your data is going to flow one way through the system. So they have some names for things, which it doesn't actually matter what the names are. It's mostly about the data flow. So you have something here. An action would be sort of like user actions, or like it would be API pushing into something that dispatches events, which goes into something called a store, which pushes through to your views. These are all your components. And then these produce more actions, potentially, which go back into here and then kind of like continue the cycle. That's kind of Flux in a nutshell. Here's another kind of way to describe, I think, more accurately what we're doing in X-ray. So it's the same thing. You have like data. It goes up through here. It renders from the top. And you saw that we had the application and all the rest of the components. It kind of pushes through the system all the way down to the leaves that get rendered. And then components might actually like cause events to happen. Like when I filter, I like change the little text box, and that causes an event to happen that changes something in the store, which goes through the system and bubbles down through the whole thing, causing everything to re-render. And I don't have to worry about any of that, mostly. So here's an example. As I mentioned, here's like, for example, like an application, right? Then we have data. And our data just looks like this, actually. And this is the data in X-ray. So everything you saw that gets rendered actually is just this. It's like a hash that has like a receptor with cells, desired LRPs, actual LRPs, blah, blah, blah. There's a selection thing, which contains our selection, our hovering state. There's a sidebar, which says like, hey, is the sidebar collapsed or expanded? And there's the filter itself. There's not a lot to it. So when things change in this data, you know, it basically goes through the system. It's like, okay, I've changed. If I, for example, like touch the sidebar, it'll go through, and it will like start at the very top. It'll render the application. It'll render the page. It'll render the zones. It'll render the cells all the way down, re-rendering everything. And because it's idempotent, if there's no change, it doesn't do anything. So great. That's why it works, and that's how it's actually fast. So that's kind of like what it's actually doing. So this is in summary kind of what I've just talked about. There's a single point of entry. You don't really need to model your relationships. You just have data like JSON. It's really nice. We don't have to like have complicated models or collections. You just deal with things that are arrays that are arrays. You deal with things that are hashes, strings, and numbers. It's like JavaScript. It's pretty straightforward. And the nice thing is here, you can see that like my application state's just a hash. It's like JSON data that you could actually persist to a server. So I could like, for example, have another application that like loaded up all that somewhere else. And you could persist your application state like seamlessly. It would be very easy to build that kind of thing. So what other interesting things are there? Well, the data in X-ray is all streaming data. That's what makes it feel alive rather than being sort of like this static application. So we have to hook it up to a data source that is actually streaming the data to us. one of the approaches that we're using to hook up to this is server-sent events. So Diego is providing like events about like the creation and destruction of LRPs based on like, you know, all the changes that are being made on the command line. You know, unfortunately, the data stream isn't actually, you can actually miss events in the data stream, or you can get false events potentially. Like, it's not guaranteed. So that's just the way that the API was kind of built. So as a result, we had to like handle both polling and SSE. So we actually poll. Something you saw me do in the demo, which was like I hit that little refresh button at the bottom. That causes a polling request to hit the RESTful API, which updates all the data. But then also in the background, it's still doing the server-sent events. And the server-sent events are basically just pushing like creation, destruction, you know, change events to us, and then we just kind of update that data structure that you guys saw. So something interesting that we found from what we built in Xray was that we had to do a bunch of work to translate the API kind of the way that we wanted. So that's a bunch of work that the client has to do that could probably be avoided if we change the API. And what I mean by this is it would be nice, for example, if the event stream that we got from the API was guaranteed to be ordered in some way that we could recognize if we missed events, or if the event stream, like, you know, if events got dropped, we could tell that like we weren't up to date, things like that. So we wouldn't have to reconcile all these things on the client. And it would be sort of nice to not have to pull Ajax pull as well as get stuff from the stream. But that's just a detail. Like, I mean, after you build it, then you kind of know what changes you need to make to an API. And it was very interesting to build this kind of thing because it's very different to think about constantly changing things that are not necessarily user controlled, things that are coming from a server from somewhere else, from some API. So unfortunately, like, not everything was like, you know, not everything went as according to plan, because these things are like, they have a lot of like problems, and it's like, and mostly, you know, React solves a lot of what you want to do, but performance is still really hard, even in that kind of system. So I can go into more detail about this, but if you guys want to talk about it later with me, I can give you details about how we actually solved the re-render problem. So I actually stated that you just redraw everything all the time, no matter what, and React kind of figures out like what to do. That's a true statement, but there's still a whole lot of work that you do when you change something, you know, when you change your data and it flows through the system from the top and goes through. You don't actually want to re-render everything if you don't have to. Like, you want to, like, if something didn't change, it's like, don't bother re-rendering, right? Because it seems like that should be obvious, even though React will say like, oh, I'm not going to change the DOM because nothing changed, right? So we have, there are some details about how we did that, mostly with immutable data structures, and I'd be glad to talk about that later with you if you're interested. Dealing with that, though, it does mean that you have to like think about those kinds of things, and you have to put them in your code. It doesn't mean that it's not free, but it doesn't have a huge cost because React is kind of built with these things in mind. You have to opt into a lot of these performance things to get them. So that was tricky. We often actually kept breaking things in it, and it's like, and you do have to be vigilant about how you're treating data in the system, especially when you're drawing something that's like a list that might have a list of things inside that list that might, that might have another list of things inside that list. So if you cause a redraw of anything outside of that, you might end up with something that's order n squared or order n cubed, and that's really bad for re-rendering if that's what you're doing all the time. So that's kind of an example of performance. The other thing that we kind of found was when we were kind of building it, we didn't have a realistic data set. And we didn't know about any of the performance problems. We just kind of built it. We kind of guessed at what we thought would be the performance bottlenecks. But those things aren't always clear. And we often like optimize the wrong thing. So as an example, on the left-hand side, you can see there were all the actual processes, the boxes, and we really optimized that because we were like, that's going to be slow. And then we had this like sidebar with all the desired stuff, and we're like, we just need to build that thing. But actually, the thing that's crazy slow is actually this sidebar with all this information inside of it, because it actually is like going through every single actual LRP in the system and every single desired LRP on the system. So it's incredibly slow for it to do that. So we had to add some like indexes to make searching faster and like going through the list. But it's like you can't tell that you have these problems until you have realistic data. So, we had to like actually deploy our thing out to catch up to see like, what it looked like, and then we would say like, oh, when like Ketchup had a whole bunch of stuff running, then it's like our stuff got really slow. Or we deployed it to Diego 1, and that was like, and we got to see some production data.
For those of you who are confused, Ketchup is a deployment environment, not a condiment.
Oh, sorry. Anyways, so the last thing sort of that was like problematic for us was that when we didn't have an exact match with the domain, and by this what I mean is when the data wasn't exactly the way that the client wanted it, it means that we have to massage that data on the client a lot in ways, and that's not actually bad, but it does mean that we have to do things like we have to resolve like changes on the client, like whether or not something's been added, removed, or changed. And we have to do that for the polling API, and we also have to do that correctly for the streaming API. So we actually do the work twice in 2 different ways because you have 2 different sets of code. And that's kind of annoying, but if we could change the API to work better with this, we would have less performance issues. So what's next for X-Ray? Well, Antti had like 7 releases of like things that he wanted to do, and we built out maybe like 2, something like that. But there's a lot more to go. Mostly it's read-only right now, and I think we'd like to like, build some of the other like interesting features that would be great for operators, like actually doing some of the same things that Antti was doing in the command line in the interface, because it's kind of nice to like interact with the interface rather than like typing in the command line all the time. We also have a new design that Monty put together for us, and we're mostly through that now. As you could see from the demo, it's changed a bit, and we're trying to like add a lot more like pizzazz to it. But keep performance in mind and make sure that like we don't ever lose track of that, because the tool is not very useful unless it's really fast. So that's all I got. I got questions.
All right, you talk about performance a lot. Under how many? When is it actually? If you did everything the easiest way possible, when would you have actually ran into performance problems? Like how much could you actually visualize before? I didn't did all these optimizations, but you shouldn't have some ideas.
Yes, that's true.
So we saw the performance issues when we had 10 cells running 1,000 applications. And that's when it like crawled to a halt. And I think now it's much better.
Yeah, so that was because we had like, we definitely had like things where we had like order n squared type things going on. Like in the list on the right, we were sorting every single thing, and then we were also sorting it on the other side. Like both sides were sorting, and it was like really, that's incredibly slow. Like actually, I can go back to it here. It'd be easier to like talk about it. So this was like, the order of these things was being sorted for each one, and we were also sorting this as well. And that's kind of crazy slow. There's other things that, you don't think that they're bad. Here we're actually, you can see, I'm not sure if you guys can see it because the numbers are tiny, but it actually says like how many instances of a given app are running. And in order to do that, you actually have, for each one of these, if you have like a lot of these, this could be like 10 or 1,000 or whatever. It's got to like go through each one of these and be like, am I the thing you're looking for? No. Am I the thing you're looking for? No. Am I the thing you're looking for? So it's like super easy to like, if you just want to draw like a small number, it's like, oh, that's actually like not optimal. So things like that. But they're all like algorithm things. And this is kind of a weird test, this is a weird thing because you can see everything at the same time, like all the time, right? You see like all the LRPs in the system pretty much. So you can't do like tricks like not render things that you're not looking at because you're looking at everything. So, but when you write a React app, you should not do any of the performance stuff at all to begin with. Don't do it. Because you don't need to. It's going to take care of that actually for you, and you only care about it if you are running algorithms that are like not order n. Right.
So it seems like it's a very like functional style. Data goes in one way, things drive code, immutable data structures, all that. You talked about having one big global data store, which was fine, but like it looked like the data model you had was pretty simple. Like it was a attachment for anything in some reason. How does what's like order patterns for using React when you have very, very complex data, like something representing many different tables in a database? Like you move to a more OO style of modeling your data at some point?
Yeah, it's interesting actually. for this, let me see if I can get one of the diagrams.
Can you repeat that question?
Oh, the question was like when the application that you've built has more complex data, and you might need to represent those relationships differently in a more complex way. What kind of techniques do you use to actually make that possible with React? Is that sort of like a good summary, something like that? So the idea here, in this diagram, right, there's like a single store, and you kind of push stuff through the system one way. But that's not to say that your application would only have one store. Like the diagram says that, but actually this could be like n stores, and there could be n different things that are independent. And that is like sort of the interesting part. So we use a concept that comes from Ohm, which is it's like a closure script thing that's like built with React and has like a lot of this immutable stuff built in mind. And they use something called cursors, which we also use as well in Xray. I have some slides about it actually here, but I didn't want to talk about it because it was like very technical. But I can get into more detail on it. But essentially the idea is that rather than modeling like stuff like you would in Active Record, like each thing and then the relationship between all those things, you don't do that. Instead, you represent you have your data as much a JSON, and it might be independent from each other. So, for example, in our data, we had like I think it's here. So we have you can see that we've actually broken these things down into separate sections. So there's a receptor, there's selection, and there's a sidebar. So those are actually separate cursors in our system. So when this changes, this thing doesn't change, right? We know that, right? And when this changes, neither of these things change. So you can actually you can think about updating the cursor points to data inside of itself, and you can update those things inside of the cursor. And they just simply go back and change the underlying data structure, so you don't have to redraw everything. And then what we do is we do a diff between what's changed in the system. And the reason why we can do that is we use immutable objects, and so we can just do a triple equality check to see whether or not something's changed or not. So I don't have to deep compare objects, which is super duper slow. That's if you have a lot of properties in your object, it's going to take forever. So those are some of the ideas, and I think I'd love to talk more about that. We can talk more about that after.
Having worked on a revamped tracker with all the UI changes, were you using React rewrite?
Sure. So the question was on track. Since I work on Tracker, do we use React for Tracker? And the answer is no. At the time, when we started rewriting Tracker, React didn't exist in a form that we could use. It came out sort of 2 years ago, I think, and the rewrite of Tracker was already well completed by then. At the very end, they sort of started looking at ideas of using React. And if you look now, if you open up Tracker and you look at and you go to and you type in React in the JavaScript console, you'll see that it's there. So they're actually using it in some places, and it actually would be a great fit for Tracker.
Yeah, I guess my question is more around. You did a lot of sort of very interesting things to get the Tracker UI to be responsive and to get all this data updated. And how much of that would go away with something like a React framework?
I'd say that, okay, so the question was there's a lot of things that we had to do to make Tracker render really quickly and maybe represent the data in a way that's fast, so that it could be rendered quickly in the way that we want. So what could we do? Well,
so
maybe.
It's more I felt like you were doing a lot of very low-level interesting JavaScript scripts in order to make Tracker UI performance and if you had had something like React before implementing a lot of that kind of interesting low-level complexity to do all that work, would a lot of that have gone away with frameworks like React?
So the question was sort of it's would things have been easier had React existed and we didn't have to do all the crazy tricks we had to do, I think, in short. Yes, so yes, absolutely. I think the thing that we could have done a lot better in Tracker was if we used immutable data structures. I didn't really get it until I started using them. The fact that you can just do a triple equal comparison to see if an object's changed, and the fact that you don't waste additional space each time an object changes, and then you can just check very easily if an array changes by doing a triple equality check. You don't have to check all the things inside the list. You just check the outside thing. That would have made things so much easier. Like, immutable data structures are, I think, a huge win, and you really need to, if you want performance, you should really think about that. If you don't care about performance, don't worry about immutable data structures because they're kind of weird to work with in JavaScript. That's why people like ClojureScript, for example, because everything's immutable. Like, there, it's like it's sort of more baked into the way that you use it, rather than in JavaScript. It's really like hard to like create a hash that has references to other things, that have arrays that refer to other objects that already exist in the system. So I think yes, I think a lot of the rendering tricks we would have like. We did a lot of cool stuff, and we could do it because like we knew about the domain. But I think it was like, but React will take care of a lot of that stuff for you, so you don't even have to worry about that performance stuff generally. Any other questions? Cool. All right. Well, thanks for your time.
Bye-bye.